The paper titled Squeezing Large-Scale Diffusion Models for Mobile presents the challenges and solutions for deploying the stable diffusion model on mobile devices with limited computational and memory resources. The authors focus on achieving on-device deployment of large diffusion models, such as stable diffusion, which have more than 1 billion parameters. The paper begins by discussing the emergence of diffusion models and their advancements in image synthesis. With the increasing adoption of diffusion models in real-world applications, the need for on-device deployment has grown. However, deploying large diffusion models on mobile devices poses challenges due to limited resources. The authors introduce mobile stable diffusion, which is based on the Stable Diffusion v2.1 model and implemented using the TensorFlow Lite framework. They achieve inference latency of less than 7 seconds for generating a 512-512 image on Android devices with mobile GPUs. The paper then provides background information on diffusion models and their ability to address challenges in image synthesis. It mentions previous works that have focused on reducing the computational cost of diffusion models and improving their efficiency. Next, the authors discuss the challenges faced in deploying stable diffusion on mobile devices and propose solutions for them. They describe techniques such as converting fully connected layers into convolutional layers, serializing convolutional layers with large activations, implementing broadcast-free group normalization, and using a numerically stable approximation of the GELU activation function. They also propose a pipelined execution strategy to handle memory limitations on mobile devices. Additionally, the authors apply model compression techniques such as quantization and pruning to reduce the memory consumption of the pre-trained model. They use 8-bit precision for weights and apply structured pruning on large convolutional layers. The paper concludes by presenting the results of their implementation. They compare the latency of their mobile stable diffusion model with previous works and show that their approach achieves lower inference latency on mobile GPUs. Overall, the paper addresses the challenges of deploying large diffusion models on mobile devices and provides practical solutions to enable on-device deployment with reduced latency and memory requirements. The architecture used to deploy the diffusion model in the paper is TensorFlow Lite, and the device they utilized was a Samsung Galaxy S23. TensorFlow Lite is a lightweight framework developed by Google that allows efficient deployment of machine learning models on mobile and embedded devices. It is designed to optimize the inference process for deep learning models and ensure efficient execution on resource-constrained devices. The key features and components of TensorFlow Lite are as follows. Model optimization. TensorFlow Lite provides tools and techniques for model optimization to reduce model size, improve inference speed, and minimize memory usage. Techniques such as quantization and pruning are employed to achieve these optimizations. Converter. The TensorFlow Lite converter allows developers to convert models trained in popular deep learning frameworks, such as TensorFlow and PyTorch, into a format that is compatible with TensorFlow Lite. It supports various model formats like TensorFlow SVD, Keras models, and TensorFlow GraphDef. TensorFlow Lite Interpreter. The TensorFlow Lite Interpreter is responsible for running the optimized models on mobile and embedded devices. It provides an interface for loading the models, performing inference, and accessing the model outputs. The interpreter is designed to be lightweight and has a small memory footprint. Hardware acceleration. TensorFlow Lite leverages hardware acceleration capabilities available on the target devices to further optimize model execution. It supports a variety of hardware accelerators, including CPUs, GPUs, and specialized neural processing units (NPUs). Platform support. TensorFlow Lite is designed to support a wide range of platforms, including Android, iOS, Linux, microcontrollers, and edge devices. It provides platform-specific libraries and apps to facilitate seamless integration and efficient deployment on these platforms. On-device training. TensorFlow Lite also supports on-device training, enabling models to be trained directly on mobile and embedded devices. This feature is useful for scenarios where data privacy, low-latency training, or offline training is required. Overall, TensorFlow Lite aims to bring the power of deep learning to mobile and embedded devices by providing a framework that optimizes model deployment, ensures efficient inference, and supports a variety of platforms and hardware accelerators. It enables developers to build applications with machine learning capabilities that can run efficiently on resource-constrained devices. Coupled with squeezing large-scale diffusion models for mobile, the future of scaling down generative AI remains very bright.